things going here. Hello everyone, welcome to Handmade Hero, the show where we code a complete game live from scratch. No engine, no libraries, just our own code, and basically we're going through every bit of game technology, every last piece that goes into having a game run, right from filling the pixels to the highest level, like pathfinding AI stuff. We are doing absolutely everything so that we can kind of see every last detail that goes into how a game is made. And right now we're kind of in the middle of a big change. We are working our way towards having a solid engine architecture. And what we're doing right now is we are finishing a change that we made where we said, okay, we're going to have this concept of a simulation region so that we can have very, very large worlds that don't necessarily fit inside a single floating point variable, right, in terms of their spans. And so that we need more complex addressing to be able to support them. Very, very large worlds, and the ability to scale up to basically as many entities as you want. So like, we have two major scaling problems. And what we decided to do to address that was to basically simulate the world in little tiny regions so that we can do stuff like have one simulation region that we open every frame to simulate what's around the player, but then we can also simulate as many other places in the world at any given time as we want to by opening other simulation regions there, and we'll just do as many of those per frame as we can. And things that maybe don't need to be updated as frequently, that are further away from you, will get simulated less frequently. So this solves both of those problems. And it's our first architectural attempt at solving them. And we're hoping it works, but we don't really know yet. I'm still sick today, so there will be a bunch of nose blowing on the stream, and I apologize for that in advance. But you can't stop coding just because you're sick. The code wouldn't get done if we just took every little excuse to stop coding. That's just no good. So what we're going to do is we're going to dive right back into it. I should mention, if you have pre-ordered the game on handmadehero.org using this little fancy button right here, and you would like to follow along at home with your own copy of the source code, you can do that. The link that you got in your email gives you access to the source code all the time. So download the zip file in there, and there'll be a bunch of zips in that file. You want day 64's zip file to start day 65. So we're on day 65, so unzip day 64 zip and start with that code. That is what I am starting with today, so you can follow along exactly if you would like. So today our job is basically to tidy things up and get to the point where we're running with the sim regions so that we can start debugging them. Now, I don't know if we'll have enough time today to actually debug them or not, but it would be nice if we could get to the point where we've actually implemented everything that we need. And are at least running, albeit perhaps running incorrectly. And that way next week we can start on just debugging and adding stuff and testing out the sim regions and so on. So let's see. We were in the process of fixing compile errors. Basically, we made our bunch of changes, and we now have to move our sim code that we were used to be doing in our kind of janky way, our ad hoc way that we were doing before. It's now time to move those over into the simulation system that we were doing. Inside the simulation system, we've got a bunch of simulation code here. And what I'm thinking, I don't know, this is just my thought, is I probably am going to have a lot of code for entity stuff. And so what I'd like to do is probably make a file that just holds all of the behavioral code, so that anytime we want to add stuff that's about like how the game world operates, that kind of goes in one file. That's not in the sim region, which is basically like the utilities and the logic for doing the sim region itself. I think I'm going to keep those in separate files. Again, there's really no rhyme or reason to how you separate things file-wise. The way that we're doing things, it doesn't matter. You can pretty much put things in files however you want. So when I put things in different files, all I'm thinking about is just how I want to be able to quickly view them and how I want to kind of mentally compartmentalize them. It's a purely psychological thing. The files, it is not really a development thing, because the way we compile is everything's all one big chunk anyway. It doesn't really matter how you break it up into files. So I'm going to make something here like handmade. I guess, what are we going to call this? We'll call it handmade entity for now. Not sure if that's a good name or not, but that's what I'm going to call it because it's basically like all of the code that you need to implement those entities. So put that in here. I don't think there's really anything for the H file at the moment. Really, we're just making those these sort of update calls. I'm going to move them in here. So those go in there. And then inside, let's see, inside the rest of this stuff, I think most of these things are going to be roughly the same. Our draw hit points code, I'm going to leave this code uncompiled for now, and we'll switch back to it in a second. Are all of these things that we're doing rendering. Rendering, I think, should just operate directly on the sim region. While the sim region is still open, we do our rendering. So we'll basically open a sim region for the world, for the place around the player, simulate it forwards, render it right in place, possibly doing the rendering and the simulation together, and then close it. Whereas with other sim regions, we won't do that. We won't basically output any rendering for it. How we want to deal with that is, again, something that we can just do a little bit further down the line. So what I want to do here is I want to change this over to be using the sim entities now. And because we now no longer ever work with low entities, basically the storage format for entities we just don't touch during real running of the game. Everything's supposed to be on sim entities except the unpack and the pack. So basically everything that was a low entity here is just an entity now. And that's really all that should have to happen as far as I know. There's nothing else fancy that should go on there. So that should just work. And it did. Now in here, again, we don't have high entities anymore in the game state. That's not a thing. We just have the sort of the final stored entities in there. So we can get rid of the high entity count. That's gone. Anything that was initializing that array is not necessary anymore. So now what we have to do here is finally something that should have been done a long time ago. Well, it doesn't, not really should have been done a long time ago, but rather that's been wrong for a long time, but we don't really have to deal with it. And that is updating the player, updating a hero. We had always kind of done that in an ad hoc fashion. We did that right in the code that parses the controller. Because again, and like I said, it should have been done a long time ago is really the wrong term. It wasn't that it should have been done a long time ago. It's that we kind of knew that we wanted to replace it for quite some time. But there really never was a need to, and you don't want to do stuff ahead of when there's a need to because you're liable to guess wrong. You always want to wait so you can actually see how things are going to go before you make changes like that. And so what we were doing here is we would process the controller input, and then immediately after processing the controller input, we would actually do the updating for the player. And that's not really what we want to do, right? We would like to probably do that. We'd like to probably do this in a way that's more sane. And the reason that we want to do that, again, is because, excuse me, we don't actually know how this controller parsing stuff is going to work in the future. It's highly likely that we might do something where both, like multiple controllers update the same player, like both the keyboard and the gamepad are both controlling the same player, for example. Like if we ship the game single player only and not multiplayer, because we don't know whether we're going to support multiplayer or not, like we right now do. But we don't know whether that's actually going to be a gameplay feature. If it turns out that it's not, then we'll want to do something like bundle the controller stuff together and so on. Furthermore, processing the controller input is something that maybe we need some logic to do to like look at, you know, maybe we change systems. There's just a lot of stuff that goes on in there. So what we'd like to do is basically have the simulation for the hero happen in the same place as everything else, and the controller processing to the extent that it happens, can either happen outside and build a little thing that it then passes on to the simulation code that says what should happen with the hero, or we actually just call out to the controller code in the hero processing and say, get it now. I'm not sure which one we want to do, but either way, this stuff here, obviously, is simulation stuff and should happen inside the simulation part of things. So, again, the other reason, too, is that there might be metagame stuff here in the controller stuff. Meaning that, like, let's say we do have an option menu, we decide to have an options menu, or you know, some kind of a confirmation for quitting. That stuff would sort of interrupt this processing, so we also have that concern. So a lot of that stuff just suggests to me that probably what I want to do, since I have to start splitting this apart, is I probably want to split apart the sim stuff, put it down inside where the rest of the sim stuff is, and then just have this get sort of passed, like the stuff that wants to happen for the controller just gets kind of passed down to the sim stuff. So when we do our entity type hero updating here, right, we can just stick in the code that we were using before for now, and that's going to be how we'll do that. And then up here, when we do our controller parsing, what we'll do is we'll just save the stuff that we actually wanted to do for our hero, and we'll process that later on. Now, we set ourselves up for success, perhaps accidentally, by having this player index for controller concept. We basically said for every controller in the system, we've got sort of a knowledge of what entity that maps to. Well, what I'm going to do is I'm just going to go ahead and expand that out. And so in addition to storing this entity reference, right? This is the entity index. In addition to storing that entity index, we're also going to store, along with it, the sort of control request that has been accumulated for that player on this frame. So we had this DDP request, right? Which is the acceleration that was wanted. And then we also had this dsword request, which is whether they wanted to throw that sword, right? So I'm just going to go ahead and put those in there. And then later on, what we'll do is the heroes, when they get processed, they'll basically pick that up from the player index for controller array. Now, what I'd like to do too, the other thing about that that's kind of, well, I'm trying to think about this. One thing that's a little janky is for the individual players. Oh, well, you know what? That's okay. We can store that binding pretty well as well. So never mind. We'll deal with that a little bit later. All right, because there's other stuff that we're gonna need as well. All right, so when we go ahead and get this this player index for controller now, what I'm going to do is expand that out into this thing, which is basically like a controlled hero or something like that. So we'll have a controlled hero struct, and that's going to be one for every controller at the moment. So when we do the controlled hero, we're going to get one of those back, and this is the controlled hero right here. So there we go. Grab that out. And this is now, I guess, like just a controlled hero array. Controlled hero, like so. Or maybe I'll say controlled heroes. So we'll grab that out, and then assuming that that controlled hero is has an entity index, right? Then we're going to do the control processing for it. Otherwise, we're going to do the same thing we were doing before. You know what? Maybe that's because it looks too close to controller. Let's do con hero like that. Makes it sound like he's a convict of some kind. Anyway, so if that happens, then all we have to do is just set up this stuff as we were doing before. So we'll record that entity index like so. And that's really all we have to do, although we could zero out as well his DDP request like so. In fact, I guess we could just zero this entirely like so. So just initialize it like that when we add a player. And then similarly inside here, when we're actually doing work on the player now, instead the DDP stuff, we can basically just, change this so that we're actually doing it directly on the con hero. One of them, and I guess there's no, the request is just kind of going to be, now that I look at it for typing, we might as well just leave them that way. We know their requests. We could even put a note. These are the controller requests for simulation, like so. Okay. So let's see here. Controlling entity, high DZ equals 3. Oh, so this was, we also have a DZ request, which is basically our old jumping command. I forgot we put jumping in there, even though we don't actually think we're ever going to allow this guy to jump. We still have jumping in there anyway. But, you know, it was kind of a fun thing, and it allowed us to test some Z stuff, so we'll leave it in for now. Let's go ahead and change that stuff. And so now we've got all of those things in there. Looks pretty straightforward. So now, when we go down here and we're actually doing that simulation for the hero, what we can do There's two ways we could do this, and I'm trying to think of which one I like best. I think instead of doing it this way, basically what I'm trying to figure out is, so we've stored this now, and then what we want to do is when we actually process all of our entities, we want to go pick up those requests that the controllers put in. And kind of one of the nice things about that is now we can have as many things as we want sort of add in there. In fact, one thing that we could do is clear it first and then add into it here. Like we could just clear out these requests fields and then have these actually add into them, which would be kind of allow us to do the controller stuff as well. So maybe we'll do that in a second as well. But ignoring that for now, what I need to do is now go pick them up. So when I iterate over the entities, what I want to do is see if this particular entity, this particular hero that I'm on, has any controller requests. There's two ways I could do that. One way I can do that is have a mapping that allows me to get from the entity back to the controlled hero. Now, I can do that pretty simply with an array lookup because there's only like 4 or 5 of these ever in the system, because there's only like, 4 or 5 controllers, separately controlled heroes on a single machine. But the other way I could do it is not doing with a lookup. I could do a loop over the controlled hero structures and look up the entities via their entity index and simulate them that way so that they get simulated first, right? That's one way to do it. And then when we actually get to them here, we wouldn't simulate them. So we would take the code out of here and just do it right here. Now, I don't actually know whether I, excuse me, I don't actually know what I think about that. I think what I'm going to do for now is keep everything in the same loop. That feels a little bit better to me, potentially. It just seems a little more rational. So I think what I'm going to do is I'm literally just going to go ahead and do it right here. And then later on, I'm hoping that as we go further into the final code, like as we get further down the line, it'll become obvious at some point later in time how exactly we want to do this, right? So I don't want to overthink it right now, since looking through 4 elements in an array or 5 elements in an array is so cheap. I think I'm just going to do that, and then later on we'll see if there's a more elegant solution to the problem when things are a little more settled. So I'm going to go ahead and see about the control index here. I'm going to go through basically all of the controlled heroes, and I'm going to say let's take a look at the controlled hero, whichever one it was here. I don't know if you can hear it. It's so loud. There's so much construction here in Seattle. Like, they're building so many buildings. There's towers going up all around me. You can hear construction everywhere. All right, anyway, so I'm just going to look and see if the entity index, right, of this con hero equals the entity's storage index, right? So basically, if this controlled hero is controlling the same hero that I am, then that's how I know how to actually do his move call. So once we get that con hero out, then I pretty much know all of the parameters that we were using before. They're just going to grab it right out of the con hero here. And then the only thing that I need to do that we didn't used to do in here, and of course we actually don't need any of this stuff anymore, the low sword stuff, we can just get the sword directly, right? That's going to be entity sword equals, what's our sim region call? We need a, what is it? It's get entity by storage index. Oh, we don't even need to do that. We actually did a bunch of cool stuff here. We don't need to do any of this garbage, right? That's just done. All we need to do now is that we just take the entity. It just has a sword pointer, right? It's just got one. That's it. So we just look to see if it's got a sword pointer. If he has a sword at all, we're done. We don't have to do any of that stuff. We don't have to do any of this stuff. This is great. See how these sim regions are going to be so good. Some people weren't so sure about the sim regions. I understand your apprehension. We're doing a lot of tricky things with the code, or trying to do a lot of tricky things, and it's hard to make them all to satisfy all the constraints. Again, we are picking intentionally much harder problems than we need to solve so that we can show how to do them. But it's really cool when stuff works out, when you can satisfy those constraints and still make the code simple, and I really do think we're getting closer there. It's not going to be the final thing, right? Like, probably a little bit further down the line, we'll have another epiphany, and we'll all be like, we can do this cooler thing that's even more cool with the way the sim regions work, or we replace it with this better concept. But you can't always jump right to the end. You have to kind of go through that process, and that's one of the big things I wanted to show on the stream was going through that process, so people could see that that's how it is. A lot of times you read something on the web and they're like, here's how we solve the problem, and they just show the solution. But that doesn't help you get better at solving your own new problems. And so this is really the kind of thing that I want to do. And look at how nice this is coming out now. Now you just use pointers. You can just point to things directly, which is how you would want to write it originally, instead of having all of these low, high indices that you had to manage. And so what we're doing here is we're getting back to the nice, simple way of programming while still satisfying all the constraints that we had, which were pretty tough, that sort of imply you can't use pointers and that you can't use floats and that sort of thing. We're getting that back while still retaining the things that would have caused us not to be able to use those originally. And that's exactly what we want, right? We want to get back to having the simplest possible code be totally just writable while still having all of these things that you wouldn't have gotten if you had just written that simple code. And I think that's what the sim region is starting to let us do, and I'm really excited about that. So we don't care about any of this stuff now. It's just this, right? But we need to, I guess we still need to set its position like so. So basically the entity's position and the sword's position are going to get set like so. And we don't care about this at all. So that is how that works. Oops. And then we also have to put our jump stuff in there. Here's our on hero. We have to put our jump stuff in there, which is to say that in addition to moving the entity there, we had a thing where we said we wanted a DZ. And so I think that's just on the entity as well. So there's a DZ. So we'll go ahead and set that. Now, yeah, we didn't actually have any logic for our jump code yet, so that's okay. That'll just stay the way it is. And let's see what's going on here. So this stuff, that goes away. Sim region. Sim arena is undeclared. That's true. We haven't dealt with that yet, so we'll deal with that a little bit later. Entity, undeclared identifier. That's a sim entity, obviously. High entity is not, and we don't need any of this anymore. That goes away. We're strictly working on the things in the sim region, right? High entity Z, that's just going to be entity Z. Let's take a look here. This is just going to be the facing direction. Again, all of these things just get simplified. It's now just, again, looking a lot more like the code you could just write directly if you didn't have to worry about all these ancillary constraints, which again is really good. I think that's what I wanted, and we're starting to get there. So let's see, controlling entity, undeclared identifier. So this is just the entity that we're on, that we're simulating. Getting down, last few compile errors. Looking good, people. So the move entity call, we need to pass the sim region to that, right? Let's see, function does not take 6 arguments. How many does it take? Move entity, sim region, move entity. It takes the sim region, doesn't take the game state, that's all. Okay. So we have our sword. That's another sim entity. I keep calling it entity. I'm thinking the fact that I type entity so often suggests to me that I probably should just rename sim entity to entity. Because it's our primary entity type now, and like I was trying to be a little more clear about the fact that it was for the sim region only, but that's the only place we're ever going to operate entities. Everything else is just for entity storage. So I probably should just rename it entity, because that's what I type all the time. And you see me type it so many times instead of the right thing. I feel like we should probably say that this should just become entity. So let's do a to-do Casey, rename sim entity to entity, right? All right, so we got that arena stuff to deal with, which we're going to deal with. I want to keep that to the end because I want to talk about that a little bit. For drawing the hit points, I think we still just draw just the entity itself. Update sword and update familiar are the two update, and also update monster are the things that we have to actually go and do. Now these are all of this stuff is off the entity itself, like so. And There we go. Let's see here. Anything else? Update Monstar. This is just going to draw the hit points. So I think we're all good. I think we're down to just the sim arena and the 2 update calls. So now to get those update calls in, I'm just going to go ahead and take that. I had that handmade entity, right? I've got those in here. I'm going to go ahead and bring those into the build by pound including them, right? Like so. Like I said, we compile everything just as one chunk. We don't compile multiple files. So I'm just going to go ahead and bring those in. And now they're in. And so now we just have to port this old code that we had. And for now, I think that should just work. We don't really need the game state anymore. I think we just use the sim region, right, like so. And then we've got our sim entity like this. And then the entity, we don't need to sort of grab it anymore. The familiar is looping over everything in that sim region. So this is just going to be a test entity index, right? This is looping over everything. And this is not probably how we want to do it eventually. So we want to put a to-do in here that says, make spatial queries easy for things so that we can do a spatial query here and not have to go do this loop sort of stuff. But again, that's a little premature because we haven't quite gotten to too much of our logic stuff yet in the entities. So basically, we have a test entity that's going to start at the beginning of the sim region entities, and then we're just going to go through all of the entities that are in there, just the whole entity count, and it's going to look for anything that it thinks it might want to follow. That's how our familiar was working. And again, we just want to, the reason I'm marking that is because we don't want to loop over all the entities ever, really, even in the sim region for an individual. We want to be able to call some queries that we can accelerate because we know lots of people are going to want to do that, and we just want to make that all kind of consolidated into one place so that we can speed it up when the time comes to kind of get perf out of it and so on. But, all right, so when we do this, we've got our update familiar call. It was looping over those things. At that point, we had a closest hero. The closest hero is just going to be a pointer now because we don't need to store lows and highs and all this other garbage, which again is great. I really like how this is cleaning up. We have the closest hero d squared. We're doing all the same checks just to see. And I think we did do pull speed out of move entity. That's the move spec thing. So we did do that. So that's good. And I think that's about it. So that just has to call the move entity call to update his position. Excuse me. That looks about right. Let's take a look. Again, that sim entity. I'm going to enjoy renaming that. I think I'm going to enjoy renaming that. These get rid of those high pointers. So again, all we're really doing is deleting the old code that was dealing with that crufty combination of things. So default move spec, we gotta, I think that's still in here. We want to move that out, and that's just going to be entity data there basically. So we'll leave that in there. Update Monstar, we haven't written yet, so that's pretty easy, but we know it'll take the sim region for sure. It'll basically just look at the same as the other calls, like this. Sim entity. We had our sword code, which basically moved the sword, right? There was nothing particularly odd going on there. And this stuff, we basically had a way that it could become, after a while, it would not exist anymore for all intents and purposes. And so we don't really have that concept yet. So we'll have to deal with that maybe as the first thing, maybe as kind of the next thing that we do in terms of tracking entities in the sim region. Right, we need some way, in fact, you know what I'll do? I'll just place an assert in here. Assert, need to make entities be able to not be there. I don't know. Not sure what we'll call that. You know what I'm saying, though. All right. So let's see. Entity high P. Don't need high no mo. There we go. And entity low, we don't need any more either. That's all in there. All right. All right. So I think that's good. These all take the sim region now. Sim region, and I think we're now back to where we were. Okay. So we have a couple things that we still have to do. So inside our handmade sim region, we do have some to-dos that have to get done. these two right here, we got to clear the hash table, and then we have to work on that apron stuff, which will also dovetail with the sword thing. But first things first, we now need a place to store the stuff that we do in the sim region. And this is the first time that I'm going to introduce this, so I thought I might take a second to talk about it. Just so it's clear, right? But I'm going to blow my nose first. Oh, sickness. All right. So, here we are on day 65, right, which is 65 hours into the coding of Handmade Hero. Still haven't gotten to 2 weeks of coding yet. So we're actually very early in the development of this game, if you think about it. 2 weeks of coding is hardly any coding. Most games have many man weeks of developing in them. So here we are on basically what is hour 65 or so. We had a couple extra hours in there somewhere, so it's probably more like hour 69 or 70. But if you will remember, way back at the beginning, I said we have 2 memory blocks. And in fact, I'll draw them separately because the game doesn't actually know if they're even continuous. Right? We have the permanent store. I'm just going to write this on this side. We have the permanent block, right? Did I spell that right? It's in E, right? Yeah, permanent block. And we have the transient block. Now, so far, we've only ever used the permanent block, right? And we put like our entities in there, right? And we put our game state in there. And it makes sense, right? Because that's the stuff that actually needs to persist from frame to frame. And if we were going to save the game, most of it would be stuff that we'd save as well. Although I don't know that we'd save it out as a block, but you know. But we never used this. And you might ask, like, why was it there? And the answer is because now we're actually starting to get into pieces of code that are going to want it. What the transient block is for is a transient block is just a scratch pad, essentially, where things that only are used for calculation go. And so what we do is we're going to divide this up in some ways, right, into basically chunks. And what we're going to do is during processing of a frame, we're going to allow things to essentially just grab a region of it, use it to do all their calculations, and then get rid of it all when it's done, right? So it's basically just a scratch pad, right, for this sort of thing. So the sim arena is the sim region is a perfect example of how this would work. What we can do is we can just grab a pointer to a chunk. The sim region can just start throwing things into that chunk as much as it wants. Then when it's done, we just vaporize it. We just say the whole thing's gone, right? So it's basically just a stack that gets cleared at the end of the processing. And again, the reason that I think this is so important is because a lot of people, the overwhelming majority of people, write code that's basically like this spider web of pointers, right? They write code where they've got, you know, the entity has like pointers to other entities, right? And then like they've got pointers to like their sim state or something. And then like there's like, you know, all of this stuff. And then there's the tiles, right? And those point entities and all these sorts of things. And they allocate, when they allocate stuff, they allocate it, create these sort of morasses, and then when they free it, they walk them and they do these frees. Okay, this guy will free, you know, this guy says free, so he tells this guy to free, and then this guy says to free this guy, and then it walks back up and all this sort of stuff, right? And they do that whether it's permanent stuff or not, right? So they write this kind of code where you're doing this kind of crazy destruction, even if all of this stuff was only transient for a bunch of computations, like in the case of the sim region, where all of it's only there just to do our calculations. What you'd much rather do is do all of this stuff in a scratch pad. So this is all in some memory segment somewhere, right? Where you do it all, and then you never have to care about crawling this list again. You never, during shutdown, there's nothing to shut down. You just say it all goes away, bam, gone. And that way there's no allocation cost and there's no deallocation cost. They're just gone, right? Allocation is just incrementing an integer. and deallocation is nothing. There's literally nothing. You just don't think about the region anymore. There's nothing to it, right? And that's really a much better way to write this kind of code. You can't leak memory anymore, and you pay no cost, no performance cost for it. So anything that you can write in this fashion, you want to. The only time you should ever write that morass spidery crawly thing is if you actually need that functionality to be able to delete just a small portion of collected entities or stuff like that. And the vast majority of systems don't need that functionality. So you're paying all this cost. And this is true whether you're in C or in a garbage collected language. In a garbage collected language, that's where all your garbage collector perf goes, right? Is if you write this code that is doing all of this sort of spidery pointer stuff, and the garbage collector is then responsible for trying to figure out how it all gets pulled back out again when you're done with it, that's that same cost, right? So it doesn't matter what language you're in, these costs are real. It's just whether you wrote code that does it or whether you let the garbage collector do it. But in either case, it's work that the CPU should not be doing, and so we don't want to do it. And so what we're going to do right now is we're going to make a memory arena, right? Because you remember we have these memory arenas. And we're going to initialize this sim arena. We will do some more fancier stuff with this later, but since this is the only thing that uses our transient thing yet, sorry, I should put that here. Since this is the only thing that uses our transient arena, we don't have to do anything special just yet. So what we're going to do is initialize that sim arena. We're going to initialize it to the transient arena's location, basically, right? And I can't remember what that was actually called. So let's take a look in the memory section. What was it called? It was called transient storage and transient storage size, right? Like so. So yeah, so I just want to go ahead and initialize that arena, and I'm going to go ahead and give it the entire space, like so. And then everything can just allocate off of that. And when we're done, we literally don't, at this point, have to do anything. Because basically, when we're done, we're done. We just return back to the platform code, and the next time through, we'll initialize the sim arena to point to the bottom of transient memory again. No cleanup at all, right? There's just no cleanup at all. So in theory, that's all we need to do for now. There'll be a little bit more stuff about partitioning later when we have more things using the transient area, but for now, that's really it. So that's all we need to do. What is this complaining about? Transient storage. Ah, I see. This should really take a void star so that you can pass any kind of memory you want, and then it'll just do its cast since it's the thing that wants it in a UNA. So we'll fix that. Begin sim. I don't actually remember what this takes. So let's take a look. Begin sim. It is sim arena game state, which I think I said I would like to not pass anymore eventually. But the problem is the low entities are stored there. And then that's it. All right. Begin sim must return a value. That's true. It must return the sim region. And add entity must return a value. That is true. It should return the entity that it allocated. All right. So we got to do a couple things here. I think the only one we want to do right now is clear that hash table, but then we have to go through and step through this stuff, and basically we've done a pretty major code change. I'm sure we've made a bunch of mistakes, especially because we had to do it over, normally I would do this whole code change in the space of one block of time at work, but since we only have an hour per stream and I'm talking the whole time, a lot of times we have to spread it out across multiple days. And because of that, we may have made some oversights where, like, I forgot to change something, or we said we were going to change something and didn't. So we definitely need to kind of go through now what all the stuff we did. Maybe we'll step through everything once and just remind ourselves whether we've done everything that we thought we were going to do, whether we actually implemented it or whether we just cheesed it out before we start debugging in earnest, because I think it's just going to be a good idea to just make sure there was nothing obvious that we left out and to remind ourselves all the stuff that we changed. So when we do this push struct here, I'm pretty sure that push struct won't clear that hash table for us, although let's double check and see if it does. Well, the hash is actually in there directly, so let's take a look here. Handmade.h. Let's see about the push struct. Push struct does a push size, and push size doesn't do a clear. So we want to do a clear here, and we don't actually have a clear call yet. So I think I might do an inline clear call. Also, these are all should be inlines. They don't do anything, so these will be things that should be put straight into the code probably. So I'm going to do a 0 size call, basically. Something that just takes a pointer, right, and a size, and just clears it, right? So it's basically something that just says, while there is some size left to do, just clear it, like so. So we basically have uint star byte equals pointer, and this is something that we probably will do a bunch of. So check this guy for performance. Because we may want to we want to write zeros in bigger blocks, and we might want to do some fancier stuff there eventually if this ends up being something that we call in a bunch of places to clear things to 0, right? So that's just something that we want to be able to do, right? So all I'm doing here is I'm just spinning over all of the bytes, right, one at a time in whatever block this is, clearing them to 0, and that's it, right? So if this comes in and size was already 0, it'll do a while size is 0, so it just won't enter this loop at all. If it does enter the loop, it'll decrement it each time through until it gets to 0 and clear as many bytes as are there. All right. So what I want to do is I want to 0 size this guy, this hash, right? And so what I think I'm going to do is just make a convenient thing, since I want to do that occasionally. I want to do something where I can just do 0 struct, right? And I can pass something that I want zeroed like this. So I can just say, oh, okay, clear that whole hash out, right? So what I want to do is do a pound define 0 struct, just like we did up here, which is just a macro that takes some instance of a struct, right? And basically it just says, okay, what I want you to do is call 0 size. I don't need that semicolon. Call 0 size with just whatever the size of the thing is that we were talking about, and then the address of it. So just clear it out as a whole block, right? And that'll work to do that clear. So that'll clear our hash table for us. And now I think we've done all the things that we knew that we had to do that we can remember anyway. So now might be a good time to, again, sort of step in there and see what's going on. Now, there's one more thing, which is I don't know if we ever end the sim. We don't. So what we want to do, oh no, we do. Okay. So what we want to do is just make sure that happens. But it looks like it does happen. Okay. So let's go ahead and do the rest of what we need to do here, which is actually debug this. I'm going to go ahead and just step in right from the start to sort of go through all of our code again and see what happens. Now, we didn't touch the adding code. The adding code still works basically exactly the same way. So I think that should be fine. So I'm going to skip over just the adding code and assume that that's still okay, although maybe we broke something in there as well. We'll find out that a little bit. We didn't really touch that code much, so I don't think I need to step through it. We'll just debug that code regularly. So what I'll do here is I'll just go ahead and start stepping in right at the point where we actually start the simulation part of things, if that makes sense. So we initialize our arena. This is where we're going to be able to store all the stuff that happens in our sim. Oh, hey, look, we're just at the end. All right, I started 10 minutes late, so really we've got another 10 minutes after the 5-minute warning. So we go into the sim region. Here we go. We're going to get out from our arena. We're going to get the size of the struct. And so now we've got one of these. I don't like the locals window. I'm going to get rid of that. Someone had asked me a question about it separately off stream, and I wanted to double check that the answer I gave them was right. So let's get rid of that. I'm a watch window kind of person. Okay, so we got the sim region. We cleared out our hash table, or at least we think we did. We wouldn't really be able to know until we come around the next time anyway, because it would have been 0 already. But we initialized some stuff inside the sim region. So we set the world pointer. We set the origin to like where we're simulating around. And let's take a look at what that origin actually was. Okay, so the origin is just straight up zeros. We set the bounds, which, there we go, that's just our camera, which looks about right. Then we set up our entities, so we're basically going to grab an array with the maximum amount of entities that we wanted to store in the sim region, which we haven't really talked about yet, and we don't really care about at this point. But you know, later on we might do something about that. So we can store up to 4,096 entities in this sim region. And then let's go ahead and take a look here and say, all right, we've got the min chunk P and the max chunk P. That's the region that we're simulating. This is the same code as before, so we're assuming that it still works okay. And I don't think there would be much of a problem with that. Looks like it does. So we iterate over that. We get out our world chunks, and any chunks that have something in it, we're going to go ahead and process. So we're kind of doing that now. And I'd like to take a look. Okay, so we found some entities here in the world. One of our world chunks had some stuff in it. So we're going to go ahead and see what entity it is. It's entity 40. We grab out the stored version of that entity, which is here, which basically has a sim thing in it. It's a wall, or in our case, it's actually a tree, but we haven't really done that stuff in the entities yet. But yeah, it's a wall tree. So we go ahead and figure out where that is relative to our sim region. So let's step into that code. We take where the origin of our world, we make that difference, which looks reasonable, as far as I can tell anyway. And so that becomes our sim space location. We get that out. Once we have it, we check to see whether it's inside the bounds of the camera, which it is. So then we're going to go ahead and add the entity, right? So we come in here, we go ahead and add that entity, and this is our two-tiered call, the one that takes a position. So it's going to call down to the next tier, which is the lowest level entity addition call. It goes ahead and checks to make sure that we've got room in the sim region for it. We go ahead and grab out whichever one it is and increment that entity count. So we now are storing one entity in our sim region. We're going to initialize the entry in the hash table so that we can get this entity again from its storage index. So again, we go in to do our mapping call. Our mapping call gets that entry, right, which computes the hash value, which right now is just the storage index. We don't do anything fancy there. And we step through our hash table, grabbing out the things one at a time. Now, what I probably should have done, and in fact, since this is the first time into this code, I'm just going to go ahead and do it. I'll set a breakpoint here. I'll stop the code. I want to go make one change there because I want to be able to inspect those values, and I can't right now because of the way that I typed in the code. I don't like that. What I want to be able to do is I want to be able to look at the hash index that we compute after we do this offset process, right? I want to look at that just so I can be able to see it in the debugger, right? And maybe we'll also go one step further and compute that mask separately so I can hand verify that as well. And again, this is just making it so that I can verify my code more easily when I step through it in the debugger and make it easier on myself, because the compiler is going to do the substitution of these anyway, so it doesn't really matter how they're set up in that sense. So we're going to make sure we have the hash mask right. We're going to make sure that we have that hash index right. I just wanted to make sure that those were clear. Okay. So we go ahead and run back to that point. This is where we were. So our hash mask is like so. Oops. Hash mask. And if we take a look at that, you can see that it masks out the part that we wanted, which is good. And then we compute our hash index, which is also should just be those low bits. 40 it is. Like I said, we started about 10 minutes late, so we'll go about 10 minutes late just to keep with an hour of coding even. All right, so we find a particular entry, and there's nothing in it, right, which is what we expect. So we go ahead, excuse me, we go ahead and return that out. And so now this person out here now knows that the entry is either 0 or the thing they were looking for. In either case, regardless, it's going to overwrite that storage index because it knows that either it was 0 or the storage that it was expecting. And then it's going to go ahead and put that entity in there. So either it's just overwriting exactly what was already there, or it's going ahead and actually putting in a new one. And so that's fine. Like, we don't care whether it was there or not. We're just going to map it again. So if we actually got back if we actually got past some entity that we're initializing this entity from, what we want to do is go ahead and overwrite the entity that we just created, all of its data, right? Which should be nothing at this point. All of its data is going to get overwritten with what the data is that we actually had, right? Which is not very much, which is just what that collides, because it's just there's not much data in the trees. And then we want to go ahead and load the stored entity reference if it has one, right? So if it's got a stored in here, we want to load that in as well. So we load that in load entity reference. We look and see if the reference index is non-zero. It's not, so we just go ahead and continue out. We're done adding the entity, and that's all we had to do. So after adding the entity, assuming that we actually were able to add it successfully, we take a look to see whether or not we got a position that we were supposed to set for this guy. We did, so we set it, and now we have set where it is. So that should actually be set to something now, I believe, right? Okay, of course we can't see. It's actually dest. There we go. There's our position. That looks valid. So we're done adding it. And then we're just going to go through and add stuff again. So let's take a look at when we actually add somebody that actually has a sword for that load entity reference. I'll set a breakpoint there. Oops, sorry. No, the sword one is what I wanted. When you actually bring someone into the set, oh yeah, no, that's what I wanted. So what we want to do is actually break when that actually becomes true. So that would be load entity reference. It'd be here, right? And so I guess I didn't actually want to run. I didn't mean to run all the way there. So let's go ahead and do that one more time. I just want to set a breakpoint at that one position so that we would be able to look at that piece of the code. All right. So after we add all the entities and we're done there, right? So now we've got all our entities added. Let's make sure that we have some reasonable values here. We added 95 entities into our sim set for the camera region, which is basically just all the trees, the Monstar, and the familiar, right? So in our sim region, we're going to go ahead and return that out. We then do some regular drawing code, nothing particularly interesting there. We then loop over the entities in this region. Oh, you know what I just realized? We forgot one piece of code already, which is that this entity pointer doesn't get updated. Oops. Oops. That's a bit of an oops. It's true. We made an oops. All right, so this entity pointer right here needs to get updated each time through the loop, right? We're stepping through that loop. So let's go ahead and recompile that so that we're not stepping through a totally bogus version of our code. We don't care about this anymore. We already stepped through that, so we kind of know what's going on in there for now. We'll step back into it once something's broke, once we see what's broke. So now we're stepping through the update code for entities. So we go through here, we switch the entity type, we find that it's a wall. So basically walls just draw stuff, so that's really not that interesting. Here's some update code. We should probably move this to another location. Now that should probably be a move entity, right? So we go ahead and do our standard drawing code. I don't think this really doesn't involve the entity so much. So really what we're looking for is we're probably looking to take, we're probably looking to get into a position where we're actually going to update someone with some kind of logic, right? And the Monstar doesn't have any yet. So let's go ahead and wait till we actually have one of those. So there we go. So if we update familiar, that's actually got some logic to it. So when we come in here, then we have our update familiar call. What we're going to do is say, all right, we're going to loop over all the entities and just see if we can find any heroes. Now we shouldn't find a hero because the player hasn't joined yet. So we shouldn't find a hero, so we should skip over this entirely. And then the move spec, when we pass this DDP, the DDP should be 0, which it is. We come into the move function. We're going to enforce a unit max acceleration vector. That's fine. This is fine. The entity doesn't collide, does it? Or it does collide. It does collide. So now we're testing over all of the entities in the test region, right? So that's pretty straightforward. We're just testing all of those things in the test region. So we'll go ahead and finish that out. We don't have a spatial partition yet, so it's just manually testing them all, which is not very efficient, but again, for only 95 entities, processors are so fast these days, you don't even see it. It's crazy how fast they are. It is crazy how fast computers are. You wouldn't know it if you used a you know, typical desktop application, you'd be like, how is it managing to be this slow? And somehow they manage. So all right, we go ahead and do update familiar. Was not very interesting. All right, so we've got a problem in, where is this happening? Oh, this is happening at the very end. We already, wait, so we didn't actually ever hit, oh, that's right, because there's no heroes added. I was like, how come we never saw the hero update? It's like, because we haven't actually joined the game yet. All right, so it looks like we stepped through everything except for the end sim, and we're getting an assertion in there anyway, so we kind of know we got to debug that one way or the other. So let's go ahead and finish stepping through everything. Let's step through that end sim. So how is that going to work? So sim entity, we go through, we grab where we're going to store it back to. We do store it back, right? And so that's fine. Then we have to convert our entity references back. So let's go ahead and make sure that that works logically. So we've got stored sim.stored, right? That's, oh, it's got nothing in it, so that doesn't actually matter. It's not going to actually update. We'll have to do that once we actually have a sword, someone with a sword. So then we're going to take a new position by mapping an old position into chunk space, right? So we've got an entity P, which is here is a position. We've got a region origin. We're going to map these in. So when we do the map into chunk space, that will go ahead and do the offset from whatever the base was, and then it'll recanonicalize it. So result, let's see here. So this may just be a bug in our old code, actually. We may not, this may not be a new, an actual bug in our sim region code. We never really even went in here and did our a final version. Ugh. Don't get sick, kids. It's not fun. All right. So, inside recanonicalized coordinates, we basically created a thing that's got some offsets to it, and now we want to go ahead and recanonicalize that. So we step in here. What it's going to do is it's going to do that divide to figure out what the integer offset is. The integer offset is 0. It's then going to take a look at that sort of quote-unquote tile index, which is really now a chunk index. We should probably rename these. So what have we got there? That's also 0, so that's not going to change. And then the tile relative version is just going to be whatever it was before minus the adjustment, right? So there it is. And then we're going to take a look and see if that's canonical. In order to be canonical, you've got to be half chunk side in meters, which in this case we are. So somebody who's getting mapped back into this space is in an unhappy situation for some reason, and I'm not sure why. So we'll have to go through, and it looks like, because that looks like it's working properly, so we'll have to see exactly who it is, excuse me, and what's going on with them. All right, so we're getting a non-canonical on this guy. What is the world chunk side in meters? Chunk side in meters is 22. 0.3999999996. So this looks like just a sort of, this looks like a float precision bug to me, because the tile relative is right on the edge of that. So I wonder if this was just a case of this not picking up the exact right number to do, right? I mean, you look at these two numbers, they're suspiciously close together. So I feel like this is just a case of the mapping not quite working properly. But at the same time, what I am interested about is that recanonicalize. I'm trying to think if I care about this at all. I don't really think that I do. Let's go out here and check. So back in the stored thing here, we can take a look at the entity structure. Will not have had any mapping done to it, so we can kind of see what we had here. This was the location of the entity, 33, -11. And so what we wanted to do is map that back into the chunk space by taking those offsets. So I think what we're seeing here is just a slight error in basically when you're right on the edge of something that's being mapped in, you just get a little float precision. That's what it looks like to me anyway. Meaning this divide is not perfectly going to round out exactly right. So it looks like it's just that is canonical, has to be a little bit more flexible and allow a little bit further off than exactly on, right? Because that's really, really close to what it should be. So I think that's basically what's going on here. So I'm going to say that we're just going to leave that for now rather than looking into it again, because I'm pretty sure that's what that is, and I don't want to go down the floating point precision rat hole just yet. We already have the to-do in here that talks about that. So I guess what I'd say is we'd need an epsilon here for now, right? Which again isn't great, but you know, we can basically say that, you know, within some precision, we're okay if these things are basically a little bit off. So if you basically say, you know, negative plus epsilon, as long as it's pretty close math-wise, we'll treat it that way. And then later on, when we come back through here, we can think about the floating point a little bit more and make sure that we don't have, you know, that we are as accurate as possible. All right. So surprisingly, that actually looks like it's sort of working. Let's go ahead and take a look here at what happens. Oops, we got some kind of a problem there with the hero. We haven't centered the camera on, well, I guess I don't know why the camera is looking where it is looking right now, to be honest. So that's a little odd. Like, I don't know if we've got some kind of a bug with where things are located, because I don't really know where the origin is. So one thing that might be interesting is, let's go ahead and check that out actually. Let's do something where we draw where we think the origin is relative to the camera, right? I just want a reference point. So what I'm thinking is, if we just take something where we do that diff, right, and we do a draw rectangle, so like at the very end, after all this, I want to do a draw rectangle where I basically draw something that's, you know, I don't know, a 10 by 10 little rectangle in there, something like this. That's just going to be, you know, a bright yellow rectangle that I can see. I'm going to go ahead and draw that at where I think things are in the world, right? And so this is going to be my origin, and my origin is going to be basically that diff. I'm just going to say, let's see, where is it? It's get sim space p. There we go. I want to do a get sim space p on my sim region. Oh, I guess I can't quite do that because that takes an entity. So what I actually want is this, subtract sim region world and my stored p, which would be whatever the sim region origin. I guess that's not really what I, oh, yes, it is what I want. So what I want is a world position that's just the origin, right? So I want that. So that's the world origin. I'm going to pass that and say, tell me where the world origin is relative to the sim region, the camera, basically, right? And then that will give me inside the diff, the point that I want to draw, right? So that's what I want to do. I just want to see where that origin is. And I don't see anything. So I think, oh, it's the upper left corner. So that's interesting. I think we may have to call it because I think we're out of time. Yes, we are. So I guess what I'll do is I'll stop here. That's where we'll pick up Monday. So we've got a couple to-dos, but mostly our stuff worked, so I think we're pretty close. But we've got 2 more things to do. Figure out why the origin is where it is. So that's one thing we want to do, right? And then the other, so we're just going to straighten out our origin situation. That might just be the way it's supposed to work. I'll have to think about that, but we'll take a look at it more closely. So figure out where the origin is, where it is, think that through. And then the other thing we need to do is we've got this, when we actually add a hero in here, we've got a problem there that we want to see what that problem is. And I think that's just the sword. Basically, when we go ahead and get that, I'm pretty sure that that's just the sword causing problems because we haven't added, we basically haven't added an actual location for things that don't exist in the world at the moment, right? And the sword is something that comes in that way. So if you take a look at the entity, the sword entity, I guess this should be the sword entity that we're looking at, right? Yeah, it is the sword. And so if we take a look at the sword, we should see that basically we've got some kind of nasty, where's the stored entity for the sword? There we go. So yeah, so it's got an invalid location, and we don't handle things with invalid locations yet. So that's our other to-do that we've got to do. So these are our two importance, right? Let's go ahead and put those out there. Add logic to the sim region to handle unplaced entities. And that's, honestly, it looks like we don't have much more to go. So I think we're pretty good. That was much less debugging than I was expecting for such a big change. So I'm feeling pretty happy about that. I'm pretty happy about that. But let's go ahead and get to the Q&A. Got about 15 minutes of Q&A here. So if you could, please prefix your question with Q:, so I can see it. And also, if you could, please make it so that your questions are pertain to something that we've done today or on a previous stream. If you want to ask off-topic questions or questions about what we're going to do in the future, please save those for the pre-stream. So come about 15 minutes before a stream starts, and that's a good place to ask those because we answer off-topic questions at that point. So there you go. Oh, hey, the bot's back. Assuming we don't go wandering too much on our own, which week has accumulated enough code base for a basic, simple, fully functional game? None. We're nowhere near that yet. We will probably be... So if you think about mapping hours, right? If you think about mapping hours, basically a week of programming time is 40 hours, right? At least, if you're doing a standard work week of programming, right? So if you look at where we are, day 65, that's essentially 65 hours in. Maybe it's a little, like I said, at most it's 70 hours in. If you count a couple of weekdays, we went a little long, right? So 70 hours in, here would be week 1 of programming. Here would be week 2, right? So you start the project here. This is the start of the project. We have done this week's worth of coding, and we are almost, we're like, you know, I don't know, a little bit further down than that. We're here on week 2. So we haven't even programmed for 2 weeks on this game yet. So we're nowhere near, like, I would expect that probably fully functional game is somewhere down here, right? Where we're like totally happy with our engine stuff. So we'd have this week, next week, right? This week or something. So I would expect, you know, we'd be somewhere down here, would be like engine, you know? So yeah, so we got a long way to go. Unless your definition of fully functional is very different from mine. Regarding high and low entities, would the following solution work? Using one entity struct, all entities are stored in one array and frequently update the entity if the entity is within camera bounds and use low frequency updating if it's outside the camera bounds. So that is sort of what we're doing at the moment, but the reason that I didn't use it so that it just is in place, right? The sim region, if I understand you correctly, you're sort of asking the question, could the simulation regions really just point directly into the entity array and update them there? And the answer is yes, we could do that. There's a reason I don't want to do that, but we haven't gotten to it yet. Basically, what I don't want to do is I don't want to say that the actual thing that we store all the time is the entity structure that people actually operate on. There's a very, very good reason that I don't want to do that, but we haven't quite gotten there yet. And so you'll have to wait a little further down the line when I actually go through. I have a bunch of stuff I want to talk about in terms of entity sim, reasons I don't want to do that. But it would work. I just don't think it would work for what we eventually want to do, because I want to do stuff that's a lot more complicated entity-wise than what we're doing now in terms of what sorts of code you can do. And so there's reasons why I don't want to do that. But if your entities were very simple, then you could totally do that. Like if they were just if you were making, you know, even if you were doing a probably even a straight Binding of Isaac clone, you could totally do that because your entities are just not that complicated, so you won't need to worry about some of the things that I want to do due to how complex I think our entities will get in terms of all the stuff they can do gameplay-wise. So yes, I don't think there's anything wrong with the solution you're proposing. I don't think it would work for what I want to do, but what I want to do is more complicated than what a lot of games, gameplay-wise, than what a lot of games have. And so if your game doesn't have that complexity, then there's no reason you couldn't do that. Because like right now we already are using one, like we already are just using one entity struct, right? It's just this. It's just sim entity. But what we're doing is when we store it back, we copy it into here. So you could just be using one if you want to. But I think it's going to there's going to be another step later down the line, and you'll see why I want to do it this way at that point. I want to keep that flexibility of having two storage states. Can you give a high-level overview of how entities work now? I get it in bits and pieces, but this week has lost me. Sure. Let's go ahead and do that. All right, so essentially what we've got, excuse me, is we have a world, right? And our world right now is separated into two pieces, in some sense, two logical pieces, right? There's the geographic piece, right? So here's the geography of the world. And this is stored as a sparse map. So basically, there's tile chunks, right, that sort of say where there's actually stuff in the world. And the reason that we do that is because the world expansiveness is actually much more massive than you could ever store in a computer. So we only want to store the places where it actually exists. And if it ends up being sort of long and skinny and snakes through places, we don't want to pay for storing them as a giant block. We want to like not store all these areas where there isn't stuff, so we don't pay the cost, right? These are the tile chunks that we have, right? It's a stupid name. Did we rename it to world chunk? Because it should be renamed world chunk, but I don't remember if we actually did that. I hope we did, but sometimes we don't have time to do all the names. Yeah, so it's just world chunk, right? So let's rename that, right? These are the world chunks, right? Like this. Now we have two parts. So this is the geography, right? And then we also have another thing, which is an array of entities. And this is sort of our logic, right? So the logical stuff basically has an array, you know, some big long array of entities. And each one of these entities stores a bunch of stuff in it, right? So entity 0 is the null entity, entity 1, entity through entity n, right? Like so. And so these are our entities. These are stored in the game state right now. So this is game state low entities, right? And this is in the world. This is the game state world. So this is how we're storing things currently. What happens is when we actually want to update something, we pick a region of the world, and that region can be any rectangle. And we then say, this becomes a sim region, right? This rectangle. that rectangle gets mapped out like so. And what it does is it iterates over the tile chunks that are inside that region, right? So it grabs out these individual tile chunks that fall within the simulation region. That simulation region is larger than the camera, so the camera is basically seeing this. This is the camera area. But we're actually doing a larger region, so the camera actually maps to a smaller area of that, right? The tile chunks that are involved here, right, kind of map in like this. Some of them are filled, some of them are not. So, you know, some of these are filled, some of these are not, okay? And for each tile chunk that actually is filled, we then look at what entities are in there. The entities are stored in the entities are stored by index, which entities are in which tile chunks. So we just go through each tile chunk and we say, what are the entities that are in there? And for every tile chunk, right? So basically every tile chunk, there's this list of entity indexes, right? They're in here. Those entity indexes, right, they point back into something in here. They're just a number which says which of the entities we want. So for the sim region on startup, we loop through these, we see which ones we've got. For each one that we've got, we then loop through the entity indices and we pull out of this array, right? We pull them out and then we put them into our sim region stack, right? So we basically have, this is the entity, this is sim region entities, right? So we pull them out into here. So now we have all of our entities that are involved, just the subset that are in this region, they're all stacked up in here, right? They all store the index where they came from so that they can write back into it if they want to. So on begin sim, that's what we're doing. We grab them all out, they all come in here. When we're done, we then write them back, right? So essentially what I could do is say this is begin sim, grabs them in here, this is end sim, writes them back, right? So all of the simulation now takes place in this array. It all takes place in floating point coordinates relative to the center of this sim region, right? So that way we, stay in float always when we're doing our sim, right? No more low positions. We only deal with that on the map. So this begin sim, in fact, I could say this here. So on begin sim, right, entity copied into sim, position translated to float, right? And then on end sim, and references change to pointers, right? So like with the sword, for example, when we had the sword slot, it's storing when it's out in this entity array, it's storing an index into the array of whose the sword was. When it's moved in here, it becomes a pointer, right? So things that were indexes in here become pointers, and then when they come back, they map back in. And then so in end-sim, we do exactly the opposite, right? The entity copied to state, the position translated to int, int plus float, so high res position instead of the low res position, and the ref changes back to indices, changed to indices, right? So that's what we do on end sim and begin sim, and that's it. So all of our simulation happens in this array, right? In this sort of thing where things are just straightforward. And why do we do that? We do it so we can stay in float and still have giant worlds, way, way bigger than could be referenced in floats without losing precision. And we also do it so we can have massive entity counts, right? Because we only ever simulate a small segment of them, we don't have to worry about how many there are, and we can also compress them in here so we can make this be a much more tighter, no matter how big our sim state gets for entities, we don't have to care. We can store them much smaller than that if we want to. And this seems pretty reasonable to me because then All of the code that we write will be very simple because it just looks at these entities that are very simple. They use pointers. They just use pointers and floats. They're very simple. They're like the code you would write if you didn't have any special constraints. And that mapping in and out is what gets us these things. So these things come during this mapping in and out. We don't have to pay for them at any other time. Hopefully that gives you a clear idea what's going on. I'm not sure I fully caught how short-lived temporary transient memory is. Is it only for single frames or longer-lived? If for longer-lived memory, how do you make sure you don't wrap around and start overwriting memory still in use? Think some homing attack which takes many, many frames to resolve. So the answer is the transient memory does not last more than a frame. You can see that right here. So here's game update and render. It's called every frame. We come into game update and render, and the sim arena, we just sort of grab it and start writing into it, right? Nobody ever reads from it. So it can't last, right? The first thing we do inside when we do begin sim is we just overwrite whatever was there, right? The first thing we do in sim region, let's see here, where's begin sim? Begin sim. You can see the first thing we do is like grab a struct out, we overwrite, we zero the hash table, we overwrite whatever was there with new stuff, right? We just totally romp whatever is there. So it only lasts just that one frame. It doesn't, and it technically lasts even less than a frame. Like basically what we're going to do eventually is it'll only last between begin sim and end sim, the transient memory for the sim anyway, and then it will just release that and other people could use it inside the same frame. How do you determine how much time each sim region should be updated if they aren't updated each frame? So we haven't quite gotten there yet. What I'm imagining we'll do is each entity will store its clock, basically, and they'll get updated sort of when you pull out an entity, you'll update it for its clock amount. That's my guess, but we'll see. We haven't gotten there yet. How does the work during this experimental phase fit into the final code? Will we be reusing most of it, or will we be starting basically from scratch? The answer is it doesn't matter. Basically, what we will do is we'll continuously move code towards good, right? And so when we have things in place that are working, we will just upgrade those to be industrial strength, which basically involves like going through all the to-dos, fixing them, and like making sure that I's are dotted and the T's are crossed. But in cases where we've done stuff where we just said, well, we're assuming we have a thing here that works, like the renderer, where there really isn't one yet, we'll have to write a whole system. We won't really be deleting things, though, in that sense. We won't be like vaporizing stuff and starting over. We'll constantly be, we always just move forwards, right? All right, I think that's it for questions about stuff we've done, which is good. We're right on time. We are right on time. So I think we're in really good shape. I'm pretty happy with this. I think the sim region stuff is good. I like the way it's going. Everything about it feels good to me so far. There's a couple things that I think are going to be tough. The apron, sim region aprons is really the only thing that I'm super worried about. So we'll have to see how that goes when we get there. But yeah, I love looking at this drawing. It's already, I think this is going to be a lot of fun. Looking at how this is going, it's already kind of fun to sort of see the path that things take through the drawing. So I'm kind of psyched that we have found this drawing package that allows us to do that. I like that. All right, I'm going to go ahead and save this off, and we are going to call ourselves done for the day. Let's close that down. And like I said, I think we're good. I think next week's going to be a good week. We'll get to do a bunch of stuff. Yeah, we're going to do a couple more entity things. Like I said, we're going to kind of get stuff a little, maybe we'll start doing some sims, multiple sim regions, and looking at how to get that working. Want to get that sort of straightened out, and then we'll move from there. We'll probably move on to animation, because that's the other big thing that we haven't tackled yet, and I want to do that. Animation, sound, and then I think it's on to the renderer. So yeah, we got some entity stuff to do, then we got to go and tackle animation, which is going to be a big topic. Sound's not going to be too big. Sound's really pretty basic. writing sound codes is not too hard. So we'll do the sound code, and then we can move on to the renderer, which is our first really big engine thing. So again, looking pretty good to me. I'm pretty happy with where we are. No big surprises so far. I think we're making good time too. Like I said, only, I don't know how many hours we're in, but like 70 hours in, not even 2 programming weeks, and we've got so much good stuff going on in that code base, so I'm pretty happy about that. Yeah. If you would like to follow along at home with Handmade Hero, you can go to handmadehero.org and pre-order the game, and you'll get the source code with it. So if you want to do that, you can do that here. You'll get a link in your email that you can download the source code every night. I upload it every time after I finish. So that's something to check out. If you would like to be kept up to date on the schedule, you can subscribe to our Twitter. If you would like to support the video series, you can subscribe to our Patreon. And if you want to check out our episode guides, if you want to discuss things on the community forums, if you want to look at ports to Mac or Linux that community people have done, News and Forums is the place to do that. So check all that out, and have a good weekend. And we'll be back here on Monday. I'm not sure. It might be an early one again on Monday because I might not be here Monday night, so we may have to move it. So definitely check the schedule, Twitter, on Saturday or Sunday. It'll tweet out when the schedule for the week is known. Definitely check that and see so that you, if you want to make Monday stream. But other than that, then Tuesday should be back to the normal time, I think. But anyway, so yeah, it might be a slightly different schedule next week. Check the Twitter bot for information on that. All right, everyone. Thank you very much for joining me. Have a great weekend, and I will see you next week.